chapter 2, summarizing graphing data, and part 2. Now we're going to concentrate on histogram. And histogram is the visual representation of the frequency distribution. Histogram is the graphical representation of the frequency distribution. Alright, so we use a visual tool called histogram, analyze the shape of distribution of the data set. And histogram is a graphical representation of the frequency distribution table. The horizontal axis or horizontal scale represent the classes, and then the vertical scale representing the frequencies. Okay. And the heights of each rectangle box correspond to frequency values. So this is our frequency distribution table. Now we just basically convert it to a graph, and then this is what we call histogram. So you list all the classes. Right here, first class is from 50 to 69, the first class with frequency of 2. There should be 2. The second class is from 70 to 89 with a frequency of 33. So here 33. Third class is from 90 to 109 and the frequency is 35. And then the fourth class is 110 to 129, which is frequency with a 7. And then the last class is from 130 to 149, and then the frequency is just 1. Okay. And you can just you can also list the frequency on top of each rectangular box. So 33 goes here, 35 goes here, 7 and 1. And right here, using the class boundary to separate classes or make it look slightly better, less messy. Okay. All right, so we easily convert the frequency distribution table to the histogram. Okay. Now, it's a graph of frequency distribution. Histogram can usually be generated using technology like Excel, definitely, SPSS, SAS, R, etc. Right? So many software. Excel is the most accessible one, so everybody have Excel, and then you can control the histogram using Excel easily. And let's take a look at relative frequency histogram. So relative frequency histogram on the horizontal axis, we're still using classes. Right? Classes go to the becomes horizontal X. And on a vertical scale, it should be the relative frequency in terms of percentage. So vertical scale is a relative frequency. We just basically divide each individual class frequency by the total frequency to get a corresponding percentage. Then we just label that. So the class goes to the horizontal axis for first class 59 to 69. Relative frequency is 2.6%. Okay. Second class 70 to 89. Relative frequency is 42.3%. Third class, it's 90 to 109. The relative frequency is 44.9%. And fourth class, 110 to 129, relative frequency is 9.0%. The last class is from 130, 149, relative frequency is 1.3%. Okay. And again, we're just converting the table, relative frequency table, back to the relative frequency histogram. Convert that to the graphical representation of relative frequency histogram. Okay. Now let's learn to interpret the histogram. So once you have a histogram, typically you want to see a normal distribution. So basically you have a bell-shaped curve. So the typical feature of a bell-shaped curve is frequency increase. Start with the low frequency and increase to the maximum and then decrease. Also, it's a symmetry. It's symmetrical with respect to the center and for the mirror image on the left-hand side and the right-hand side of the center. Okay. And let's take a look at this frequency distribution table, histogram we constructed. And then we can fit approximate bell curve here. That tells us that this is approximate normal distribution. And center is somewhere here, right? It should be the center on the bell curve. Right in the middle, so if you look at the center of the bell curve, half of data should be below the center, half of data should be above the center, and form a mirror image based on the center right here. And if you look at the variation, it's pretty consistent here because we can fit a normal curve. And then we will see that outlier typically occur in the left tail and right tail, somewhere there, right? On both tails. That's where the outlier occurs. Okay, you see the outliers. And we do have a skew distribution. Typically, if it's not a normal distribution, then we have the skew distribution. Okay. And we have the skew to the right. If have a longer right tail, meaning positivity is skewed. The longer right tail, for example, like this. Right, this right tail has longer right tail. Then this is skewed to the right. That means most of data are condensed on the left-hand side. Okay, and then we also have a skew to the left, something like this. So you got longer tails on the left tail. So this is skewed to the left, longer left tail. And again, we can see that most of data will be located on the right-hand side of the center. That's what happened to the skew to the left. Now let's take a look at all these different graphs. First one, this is what we call the normal distribution. We can fit a bell curve here. And that tells us this is approximate normal distribution. One more time, the frequency increase from the small value all the way to maximum here. After that, it decreases. It's approximately symmetrical with respect to center. Okay. Yeah. And then right here, this you can fit a curve here. Look like it's a skew to the right. Because we have a longer right tail. And if you look at all these frequencies, most of the data will be concentrated here, right? So that means most of data value are located on the left-hand side of the center. Center is here, left side of the center. Okay, and this one is skewed to the left. You can feed a curve here. Again, we have a longer left tail, so this is skew to the left, longer left tail. As you can see, most of the data will be located on the right hand side. So a typical feature. And then if you look at the last graph right here, this is what we call a uniform distribution. You see a rectangular shape, and this is a typical uniform distribution. We're going to talk about the uniform distribution in chapter 5. But as you can see, for all these different classes, they have approximate same frequencies, right? Meaning same probabilities. Okay. And if you want to make assessment about the normality with a normal quantile plot, so normal quantile plot could be interpreted on the following criteria. If we have a normal distribution present, the points are reasonably close to a straight line. If it is not a normal distribution, then points not reasonably close to a straight line. Points show some pattern, some systematic pattern that's not straight. So now if you look at this, out of all these three graphs, this one is closest to the normal distribution, because all these points are very close to the straight line. You see the different distance here from the points to the line is very minimal. So close to the normal distribution. And this one definitely is not a normal distribution. All these points are very not close to the. It shows a different pattern here. It looks like exponential, growth here, right? So it's not a normal distribution. And the first graph is approximately normal. Normal distribution. Again, because most of the points are very close to the line, we only have some points that are further away, but most of them are very close to the line. So yeah, that's approximate normal distribution. Okay.